This is Professor Venkatachalapathi, Institute of Aeronautical Engineering. In this class, I would like to discuss about pattern allowances. In the earlier classes, I have discussed about the basic concept of casting, and in that the main flow activities of the casting process. Apart from that, we have discussed about the pattern, and next another important topic is pattern allowances. Look at in this pattern allowances, as we have discussed about the pattern can be defined as it is the replica of the original casting. It is the replica of the original casting where the components of any complex shape can be easily manufactured through the metal casting or sand casting process. In that, the first and foremost important thing is a pattern. How do you prepare the pattern? And in that, another important term is pattern allowances. So this is a very important topic while designing a pattern. So there are some allowances which are responsible for the difference in the dimensions of the casting. So for example, you can see there are some allowances which are responsible for the difference in the dimensions of the casting and the pattern. So especially whenever all metals are shrink except bismuth. So like that, whenever you are going to be designing a pattern, or when you wanted to do some type of patterns and all, so some allowances should be considered when you wanted to design the pattern in any type of castings. So basically, according to the usage and application of the casting, the various pattern allowances are very, very important in this context. The first and foremost thing is shrinkage allowance or contraction allowance. So shrinkage or contraction allowance. And second important thing is machining, finishing allowance. Third important thing is draft or taper allowance. And fourth important is distortion or camber allowance. And last but not least, shake or wrapping allowance. So here I would like to share one important idea of this allowances. Why you are going to provide these allowances according to the 5 different type of allowances. That is what all metals are shrink except bismuth. So similarly, like that, either it may be wood or metal piece or ceramic or plastic, any type of material, it may be shrink by pouring the molten metal. Automatically, suppose for example, if a component such as, if you take, this is a component, and when you wanted to apply the shrinkage allowance, before shrinkage what will happen, after shrinkage what will happen. So for example, this dimension is say 100 and this is 50. So after applying this shrinkage allowance, this dimensions would be 102 and 51. So that is depending upon the applying of the allowances, it can be changed. It will contraction and expansion, and wherever depending upon the solid or liquid or solid liquid types, it may be classified. Okay, so we'll discuss in detail about the step-by-step process of the different type of allowances. So first let us see, and in this pattern allowances, another important thing is the functions of pattern. So before going to discuss about the pattern allowances, let us recap of the pattern. What is the functions of the pattern? So in general, I have explained pattern is a replica of the original casting, and at the same time a pattern prepares a mold cavity for the purpose of making a casting, that is what exact shape of the component which can be reproduced by using the pattern. So here the pattern, it should have some projections, that is what code prints, and if the casting requires or needed to be hollow. So for example, if there is a hollow portion is there, you are supposed to put some cores or core prints. Core prints is nothing but it is the extra projections of the core. So whenever a component is there, a rectangle component, and when you wanted to make a hollow portion, so in this hollow portion, obviously you can able to use some cores. So in the cores, by putting in the mold cavities and all, some core prints or some projections can be made. So that extra projection, we can call it as a core prints. And another important function of a pattern is pattern can be properly made and have a smooth or finished surface. So that is what, if you wanted to get a exact component, you should have some finish and good surface finished component of the pattern. Then only you will get the final. Suppose if any unfinishing or some extra particles will be there, that leads to be defect can be obtained in the final casting. Okay, so that is why you can assume that a pattern should be, it is a cleanly and good surface to pattern. So then only you can able to have sound casting. And another function of a pattern is this can be constructed patterns which minimize the overall cost of the casting in general. So depending upon the number of products should be produced. For example, if you wanted to produce 1,000 components, or if you wanted to produce 10,000 components, when you wanted to produce 1 lakh components, so depending upon the production of the quantity, generally we will select the metal piece pattern. More mass production, obviously you can use it to produce metal piece pattern. Or suppose if you wanted to have a limited number of components, obviously you should go for the wooden piece pattern. So this is what about the some basic function of pattern. And now let us see how we can able to discuss about the this shrinkage allowance. Yes or no? So coming to this shrinkage allowance. So whenever all metals will shrink except bismuth. So that what, either it may be ferrous or non-ferrous or ceramic, any type of metals. When you pour the water also, it may be shrink depending upon the material. So obviously in the metal casting also, after preparation of the molten metal, when you pour into the mold cavity, immediately it will shrink. Shrink in the sense it may be expand or it may be contract. So depending upon the application of the casting, we should suppose to provide the how much amount. For example, shrinkage allowance, generally it can be units of the shrinkage allowance is mm per mm. So for example, 1000 mm per mm, or sometimes it may call mm per meter. Okay, so depending upon the volume of the pattern and how you can able to prepare the pattern, and obviously what type of the outcome of the casting, that is also plays an important role. Based on that, you can able to select the material, what is the shrinkage allowance for that material, for a mild steel and for cast iron, for other type of material, what are the some specified shrinkage allowance will be given for the design engineer. Based on that, you can provide the shrinkage allowance of the component. So in general, whenever by pouring the molten metal into the mold cavity, it will shrink. That shrink in the sense there will be solidification occur by giving the some cooling time or solidification time. What will happen? Internal cross linking of the all the metals and all, so that it may be expand or contract can be occurs. So that's why solidification, after solidification of the metal from further cooling, so that is when keep it at the room temperature. Whenever they pouring the molten metal, the temperature will be more than 1400 degrees centigrade. So whenever by giving some solidification time, it will come to cool. So whenever it may be cool, some pattern size may be increases. So that is why it will be increases. That increase or change in the dimension, we can call it as a shrinkage allowance. So majorly the shrinkage allowance will depends upon the main important parameters. First, dimensions of the casting. Depending upon the dimension, if it is a 10 mm size, what will be the apply the shrinkage allowance? If the 100 mm, how much amount of shrinkage allowance should be provided? The dimensions also plays an important role for applying the shrinkage allowance. And design and intricacy of the casting. If it is a regular component like rectangle piece, okay, square piece and rectangle piece, what are the amount of allowance should be provided? That is simple. Suppose some complicated and intricate and some different type of components, how much amount of the shrinkage element should be provided, that is also very important. And resistance to the mold to shrinkage. So whenever the mold also by ramming also, what will happen, the uniform ramming is there or any appropriate ramming is there, that resistance should be uniformly can be done, otherwise shrinkage may be occur. And molding materials used, what are the different type of molding materials, depending upon that also we should shrinkage allowance will be provided. And method of molding, that is either hand molding you are using or machine molding using. There are two type of molding techniques. One, the human being can be take a drag box and co box by putting the sand under, by putting some rammer. Okay, so by manually some if you put ram, usually the uniform ramming occurs in the first fresh hours. After a certain period of time, the human has less energy to do activities, so that at that light ramming will be there. So automatically, if the ramming, proper ramming is not there, it leads to be some extraction and some contraction may be occur. And another important thing is pouring the temperature of the molten metal. So when you wanted to pour the molten metal into the mold cavity, the pouring time should be calculated as per the design activities, that is sprue, runner, ingate. So what is the sprue? Sprue is a tapered, how the molten metal which will enter through this sprue basin into the sprue, and there will be a runner and ingate. So these three is the very important parameter for generating the sound casting. So that is what the pouring the molten temperature, it is a less than a minute it should pour. Even it will exceed the time, the molten metal will overflow. If it is the reduce the time, so some what will happen, some short molding also will be occur. So that is why the pouring temperature also should be maintained with the fraction of second to be pouring of the molten metal. It leads to be some damage may be occur. So that is why the majorly for shrinkage allowance, it can be depends upon the dimensions of the casting and design and intricacy of the casting. And third, resistance of mold to shrinkage, and what type of molding material to be used, and what type of method of molding to be used, hand and machine molding, and the pouring temperature of the molten metal should be maintained properly. So that is, if you should not exceed more time. So definitely the temperature may be decreases, and in the decrease means cannot fill properly, it overflow occur, that leads to be a lot of damage into the mold cavities and all. So in this figure you can see clearly the required casting size and actual size. So you can see required size initially below, okay, and the actual. So whenever after pouring the molten metal, it may be expand or contract. So that is what shrinkage or contract allowance is. The difference between this is the shrinkage allowance. Okay, so if you made a pattern, suppose when you wanted to had 100 mm size of length, automatically 1 or 2 mm of length should be prepared. Then after pouring, it will come to 100 mm. So if you take the 100 mm size pattern, after pouring, what will happen? it may come to 98. Okay, so that is why all the these are the some design parameters for pouring the molten metal into the mold cavity. But the first and foremost important thing is shrinkage allowance should be provided to get the sound casting. So here you can see some of the typical allowances. Typical allowances, for example, the cast iron, the measurable range is 0.8 to 1%, and steel it may be 1.5 to 2%, and aluminium 1 to 1.3%, magnesium 1 to 1.3%, brass is 1.5%. These are the some specified allowances should be measured while making the pattern and pattern design. So in general, shrinkage elements are incorporated into the pattern by using shrink rules. Shrink rules in the sense whenever it may be expansion or contraction, depending upon the if it is an external part, it will contract, internal part it may be expand. And also thermal contraction might not be the only factor determining the pattern size. So there will be while pouring the molten metal into the mold cavity, the thermal contraction, temperature, heat transfer also will not be the only factor. Different sizes I have discussed earlier. These are the some of the factors which will be depends on the by applying the good shrinkage allowance. Okay, and similarly surface finishing and operations should be taken into the consideration. So whenever by providing this 100 mm 1 or 2, if you take that pattern, and obviously will achieve the 100 mm. If you take some 100 means it will come down to 98. Even 1 or 2 mm is used for the some finishing also can be provided in the sound castings. Okay, now look at the another important thing to be discussed. What are the reasons for allowances in solidification shrinkages? So look at in this graphical representation. In the x-axis the temperature and y-axis may be the height of metal column. So whenever the initially the solid, and this is a solidification shrinkage, then liquid. So here there is a melting point. Initially in the molten metal preparation, first they can use the reused castings and some pig iron and some amount of materials, phosphorus, copper, etc. Some components should be added, and once it has been achieved the melting point, then it will become a liquid, and this in between the liquid to solid line we can call it as a solidification shrinkage. Especially the most of the metals undergo the noticeable volumetric contraction when it is cooled. So okay, so there are three different type of principles should be applicable in the solidification shrinkage. First one is shrinkage of the liquid, and second one is solidification shrinkage, and third solid metal contraction. These three parameters are very important in the shrinkage, the stages of the shrinkage. So in general, solid, liquid and solid liquid, three different type of shrinkages also will be more useful for providing the shrinkage allowance. Okay, next look at another important thing is draft allowance. So the second important type of allowance is draft allowance. When you are discussing about the draft allowance, look at the first diagram and second diagram. So first diagram is there will be a distorted casting, a square or rectangular block is there. The pattern also same, it is in a vertical shape. So when you put in this pattern, automatically what will happen? It may be break. The sand and all will be break because exact amount. Okay, same amount can you wanted to fix it. What will happen? It cannot. For example, if you take, so this is a pen cap. So here you can see, well, this is how much taper it is. We can easily suppose it cannot. Here also some taper will be provided. Okay, if you put it, if you more pressure, here this cracks may be provided. So that is why in the draft allowance, when you wanted to lift, so you can say if you do like this, it cannot liftable. So suppose if you use this, you can easily liftable. Okay. The second diagram, tapered. So this is what draft allowance. Draft allowance means you should apply at the vertical, wherever the vertical shape is there, you should apply some allowances in the internal and external draft. In general, there will be two important, 1 degree for the, you can provide for internal, and external is 2 to 3 degree can be used for the draft. Okay. So if you provide like a tapered form, the pattern also can kept final pouring the mortar metal also easy can be liftable with the help of draft spike, etc. Okay. So here the main important parameter in the draft allowance is wherever the straight pattern, straight size pattern, vertical patterns will be there, automatically you should provide some taper. When you provide the taper, can be easily liftable by the component. So this is what about the draft allowance. The main guidelines of the draft allowance in a design consideration. In expendable mold casting, draft facilitates the removal of the pattern from the mold. That is what I have been explaining. Draft should be 1 degree for sand casting, and in a permanent mold casting, purpose is to aid the removal of the pattern from the mold. That is, draft is 2 to 3 degrees. Okay, external. So similarly, taper should be allowed to if solid cores are also used. So for example, when you wanted to have some hollow portion, obviously you should provide some cores. Even that cores also should be tapered one. Otherwise, that mold cavity sand preparation like distortion, breaks will be occur. You can compare this, how the difference by applying the draft, how the pattern will come easily, and without applying the pattern, this may be disturb either mold cavity, and the pattern also some disturbance may be occur. So this is what about the draft allowance. And coming to the another important type of allowance is distortion or camber allowance. What is meant by distortion allowance? So here distortion or wrapping allowances. When you apply the pressure or force, it may tilt to some break, some changes its shape, some irregular shape. So for example, if there is a component like this, in the distortion camber allowance, what will happen? It may change its position to like this. Some distorted its shape, and some irregular shape may be occur. Okay. So this is the allowance which is taken into the consideration when the casting products of the irregular shape. So for example, even if it is a shape like this also may be shrink. That is a camber distortion may be occur. Some apart from this. Okay, some distortion changes its shape, regular shape. Okay, so the events of U shape. Okay, and this after applying without forming like distortion and all, you should provide some distortion and camber allowance. Automatically, it may be get effectively the final component. So like this, like irregular shape may be obtained. So, and either it may be U shape or V shape, any some what you call some irregular shape will be there. Obviously, you should be able to provide some camber allowance or distortion allowance. So it is a long flat casting. Whenever a very long type of parts can be used, this also can be applied. And one portion of the casting cools at the faster rate. So that is what, if you see here at the downward level, some difficult to fill the molten metal. That is what sharp corners also there is no filling will be occur. That leads to be some drawbacks and difficulties may be occur. So this is what about the distortion or camber allowance. Okay. So next another important allowance is finishing or machining allowance. In this machining or finishing allowance, majorly any component after producing, we need some surface finish, we need some finishing. So whenever after making the component, again you want to have some rough surfaces will be there. To remove the rough surfaces, some technique, some metal removal process by applied either lathe or milling in any type of process, some material can be removed. Then only we'll get the final finishing or machining component will be occur. That leads to be the final good sound component. So suppose if it is a 100 is there, by applying shrinkage allowance it will become 92. If you are not applied the machining allowance, that 98 become again 2 will be reduction, 96 will come. So that is why even for machining allowance also you can add 2. You can add 2 So because some extra projection can be removed to have a better surface finish or smooth finish, or machining finish can be occur. Okay, we can see in the diagram, we can clearly understand that what is the actual size and what is the pattern size. Pattern size is outside is there, actual size is inside is there. So after getting the component, definitely this amount can be removed so that you will have a good or quality or better surface finish component may be obtained. So you can see this is what machining allowance also a final component will be obtained. Then you can provide, if you don't provide the machining allowance, the size of the component may be reduced by if you do the some finishing occurs. Okay, and in this machining allowance also it depends upon some important parameters such as what type of machining operation. So this is very important. After finishing the component, what type of machining operations can be used, and what are the characteristics of the metal. So metal, either you're using ferrous metal or non-ferrous metal, and what is the important characteristics of the material. If you are known that characteristics, then only even by applying the less machining allowance also the final output will be good. And similarly, what are the methods of casting? What type of casting method can be used? Either it may be sand casting or centimeter casting or die casting. Different type of castings are there that we'll discuss in detail in the next session. And here what I wanted to say that this machining allowance also to be provided based on the machining operation, characteristic and methods of casting. And another important thing is size, shape and volume of the casting. So this is what important. Either it may be rectangular size or triangle or a square. And what the shape means, either it is a regular shape or irregular shape. And what is the volume of the casting? It is a simple, very less volume or a high volume. And how many number of mass production also plays an important role. And the fifth important point is degree of finish is required in a casting. So that finishing also very important. For example, if you see spark plug, when you wanted to make a spark plug, exact the finishing should be like a mirror finishing. If you are not mirror finish, difficult to fit into that two-wheeler spark plug. So that is why there you should take some high quality measurement for degree of finish required in a casting. Obviously, some machining allowance should be provided. If you are not provided, some amount can be removed so that it is a under length component. And the configuration of the casting also very important. So what are the configuration, shape of the component? It is a simple in shape, very complex in shape, or variety of application we are using. That is also very important. That's why This finishing or machining allowance majorly depends on the first is machining operation, second is the characteristics of the metal, and third one is the methods of the casting, and fourth one is size, shape, and volume of the castings, and fifth one is degree of finish required in castings, and finally configuration of the castings. So this is what about the machining or finishing allowances, which indicate how much larger the rough casting should be over finished casting to allow sufficient material to ensure, that is, make sure that the machining will clean up all the removal process, extra unwanted surfaces can be eliminated by this machining allowances are provided. Okay, if you are not provided the machining allowances, definitely it lead to be some difficulties may be occur. Okay, so this is what about allowances, types of allowances. I hope uh, understand about the 5 different type of allowances. One is the shrinkage allowance, machining allowance, draft allowance, distortion or camber allowance, shake and wrapping allowance. This is also last one I would like to discuss. Let us see what is meant by a shaking allowance or wrapping allowance. So in the shaking or wrapping allowance, it will be very important allowance. Here also the pattern will be shaken or more wrapping will be occur with the some rammer and all. What will happen? Somewhere it is more pressurized sand will be there. Some side some uneven pressure will be there. Obviously, depending upon the material also, either it may be wooden pattern, or either it may be ceramic pattern, or either it may be metal piece pattern, how it will be do for shaking. Automatically by shaking the pattern also will be changed. If the metal pattern can be used, it will be withstand effectively. Some wooden pattern by applying the more shaking, it will tend to move. So obviously if it is the more mold sanding is very loosened, means automatically it leads to be some defect may be occur. So that is why here also some it is shake allowance, which is also called the some negative allowance should be provided on the pattern wherever it will be kept smaller in order to compensate the enlargement of the mold cavity due to wrapping. Okay, so the magnitude of the shake allowance can be reduced by increasing the taper. So that is why where here also like what you done like in the draft allowance easy removal of the pattern, here also little bit increasing the taper, so that even if you do shaking also it much not deviate of the pattern and final casting also. Okay, so to take a pattern out of the mold cavity, it is slightly wrapped or detached from it mold cavity, so the cavity is increased in a little. That is why by removing even some patterns are fixed hardly because of machine molding process, it is very difficult to remove the pattern. At such cases automatically some shaking is required, not large amount of shaking, little amount. In that little amount only the pattern can be detached easily, otherwise it is very difficult to remove the pattern. Okay, so these are the 5 most important allowances which are very important while designing a pattern and while applying the allowances to get a good sound undefected component in a metal casting process. Okay, I hope this is what about the allowances, pattern allowances, and in the next class we are going to discuss about the what are the different type of castings and what is the definition and advantages, limitations and applications of the different type of castings, and especially special type of castings also will be there, that we will discuss in detail in the next session. Okay, so thank you, good luck.
Like, share and subscribe. Hit the bell icon for more updates.